the kinetic molecular theory unit. This last little topic is about a phase diagram, which is just reading a graph. Typically, people find these pretty easy and straightforward, but your phase diagram is going to show your state of matter. So solid is always on this side with your coldest temperatures. Liquid is in the middle of this little Y area all the time. And then your gas is at your highest temperatures. Now with your solids, your liquids, and your gases, they are not only temperature dependent, but they're also pressure dependent as well, which not a lot of people think about. This is why pressure cookers work and things like that. So this shows that your pressure is increasing. In this case, the scale is using ATM, atmospheres, and your temperature is down here, it's using degrees Celsius. So your phase diagram tells you, with your pressure versus your temperature, your state of matter. With your pressure versus your temperature and your state of matter, you have solid, liquid, and gas. There are some other points that you need to be aware of. The first one is called the triple point, triple meaning 3, and then you also have your critical points. Now your triple point, the first one, is your solid, liquid, and gas coming together, 3, triple, at one place. So with this, the solid, liquid, gas coming together in one place right here, it is where all 3 states of matter overlap one another. It's saying that they are occurring simultaneously or in equilibrium with one another, which just means at the same time. So at this point right here, you have your solid state of matter, your liquid state of matter, and your gaseous state of matter all coming together right here. Now I do have a video to show you. Oh, I should. With this video that I have to show you, this is a teacher teaching her class. I should have done this ahead of time, I'm sorry. And with this teacher, she has the it's in a bell jar here.
You can see there's kind of a
this is water.
Boiling. There's not as much. And
it's about to happen.
Did I explain why we have those stones in there?
No.
They're called boiling chips, and they just make it so that when it boils, it's not like it all splashes out. They kind of just allow for a more even boil rather than a rolling boil that would kind of spill over. And
Okay, so what she's doing is she has the bell jar on there, and she is decreasing the pressure. When she decreases the pressure, it is causing the water to boil at room temperature. So as the pressure goes down and down and down, eventually the liquid water, so right now it's boiling, so it's turning into a gas, is going to hopefully have a solid as well. So we're going to see that here happen in just a second.
potentially kind of ruin the integrity of the experiment. So they're not doing anything other than just helping the boiling process to... There it goes. And you can see it should still keep freezing, and then as it freezes, you'll see it boiling below the surface a little as well. Can you see that there? Is it the ice forms? It's also boiling.
There's the solid.
So you've got your three phases: your gas
liquid
phase, your solid phase, your liquid phase, all existing at the same time.
All right. So the solid, you can see the solid ice on the surface. So she's boiling water and freezing water at the same temperature. The bubbles mean that it's a gas, and then you also obviously have the liquid there as well. So at the triple point, you have all three states of matter happening at the same time. To find the triple point, it is where all three states of matter intersect. So it's at that point on the Y. All of these graphs will always have a Y shape like that. Now the critical point, I'm not actually going to show you this video, but the critical point is the point at which you can no longer have a liquid or a gas. The critical point right here just means that your temperatures and your pressures are too extreme, and with those being too extreme, after that you make a new state of matter. The new state of matter is called a supercritical fluid, which has different properties than a solid, a liquid, or a gas. So that is one of your new states of matter that you probably haven't heard of before. This video does show a supercritical fluid, so if you're curious what it does or what it looks like, click on that and go through it, but I'm not actually going to show it in this just for the sake of time. Now with your triple point and your critical point and your phase diagram, let me move this over real quick, sorry, you are showing not only the state of matter, but you're also showing where your state of matter is changing. So on this line right here is where a state of matter change happens, or on this line, this is where a state of matter change happens, or on this one. It's in between the two states of matter. When you're moving between a liquid and a gas, when you're on that line, you are in equilibrium with one another, so you actually have both states of matter happening at the same time. So they are coexisting with one another, which is also called in equilibrium because you're kind of in flux between the two states of matter. Same thing happens here if you're between a solid and a liquid. Anywhere on that line, you have both states of matter happening at the same time because you are transitioning from one state of matter to another. Every pure substance has its very own phase diagram. They're not all identical. They don't all melt and freeze at the same temperature. You don't have state of matter changes happening at the same pressure and temperature. So every pure substance has its very own phase diagram, and you're going to see a few of them as you go through your assignment today in Schoology. So looking at this phase diagram, you have your solid state of matter here, liquid is always on the inside of the Y, and then you have your gas state of matter here. Now, types of questions that you might ask. You might be given a point, like where this little cross is right there, and it might give you a temperature versus a pressure, and it says, what state of matter is this? When you find your temperature on the bottom, your pressure on the side, the point is right here, that would be a liquid state of matter. So again, it's just reading a graph. If you're like somewhere over here, based off of that temperature, that pressure, again, that is a gas. Now it also might say, hey, you have a point that is right here. And if you have that point and your temperature increases, what's going to happen? So if my point is right here and my temperature increases, which means it's going to cruise across this way, I'm going across the line from a solid to a liquid. So if I go from a solid to a liquid, that means that I am melting. If I continue to increase my temperature, so increase my temperature, increase my temperature, increase my temperature, I moved from the liquid state of matter to the gas state of matter, which means that I am going through evaporation, liquid to a gas. So it can tell you what is going to happen if you change your temperature or you change your pressure. If I'm right here and it says your pressure decreases, what happens to the state of matter? Well, if the pressure decreases, the particles are able to spread out. So they're going to go from the liquid state to the gas state. So looking at this, you have to remember that your pressure's over here, temperature's here, and then you have your state of matter changes. And this is showing your sublimation versus deposition. So the questions overall are pretty simple when you're looking at your phase diagram. This might help as you're going through, but everything is temperature and pressure dependent. Triple point is right here where all three states of matter come together. Supercritical fluid happens after the critical point, which is up here at the end of the line between the liquid and the gas state. If you guys have any questions, make sure that you ask. My email is mgable@crosbyisd.org. Otherwise, have a great day.